Welcome. Today we're diving into an advanced topic, steering large language model behavior without the need for expensive and time-consuming fine-tuning. LLM steering refers to the techniques we use to guide a pre-trained model to produce outputs that align with specific desired criteria or tasks. Controlling LLM outputs is crucial for various applications, ensuring safety, adhering to specific formats, or maintaining factual accuracy. While effective, traditional fine-tuning requires large, labeled datasets, significant compute resources, and can be slow to iterate on new requirements. This is where prompt engineering comes in. It's the art and science of crafting inputs to elicit better, more controlled outputs from the LLM. System instructions are powerful. They allow us to set the context, define the model's persona, and impose hard constraints on the response format. In-context learning, often called few-shot prompting, involves providing examples directly in the prompt to teach the model the desired behavior without updating its weights. Chain of thought, or COT, prompting instructs the LLM to articulate its reasoning process, leading to more complex and accurate responses, especially for mathematical or logical problems. Retrieval augmented generation, or RAG, is a technique that grounds the LLM's response in verifiable external knowledge sources. RAG works by first retrieving relevant documents or snippets from a database based on the user's query, and then including this information in the prompt for the LLM to reference. This significantly improves factuality and reduces quote hallucinations by ensuring the model's answers are anchored to specific, provided context. Beyond the prompt itself, we can also modify the model's decoding strategy, influencing how it selects the next token in the response sequence. Parameters like temperature control the randomness of the output. Top K and top P sampling limit the vocabulary the model can choose from, further steering the generation process. Adjusting these settings allows us to precisely control the balance between the model's creativity, ideal for brainstorming, and its predictability, essential for structured data generation. Even without full reinforcement learning from human feedback, or RLHF, concepts from human alignment can still be applied at inference time. We can utilize preference models or reward functions trained separately to dynamically rank and select the best responses from multiple generated outputs, choosing the one that best aligns with human values or task requirements. Implementing guardrails and safety filters is another non-fine-tuning method. These are separate models that check outputs for undesirable content before they are delivered to the user. These methods provide powerful, flexible, and iterative ways to guide LLM behavior without the high cost and complexity of full fine-tuning. We covered prompt engineering techniques like COT, retrieval augmented generation for grounding, and adjusting decoding strategies for creative control. The future of LLM deployment will rely heavily on these runtime steering techniques, making AI safer, more accurate, and more adaptable across diverse applications.